Dear students, today we are going to see about this block diagram representation of continuous time LTI system. So already we have discussed in the class that a continuous time system, so that can be represented by a differential equation. Okay. So the main objective of our discussion is, so you need to define block diagrams and their components, and also to represent a system using a block diagram. So a differential equation will be given. So using that differential equation, you need to write or make a block diagram of the system. So first we need to understand what is a block diagram. So block diagram, it is nothing but a graphical representation of a system. A system is there, right? So it may be having several components. So all these individual components will be represented as a block diagram, or we can say it's nothing but a mathematical pictorial representation, a pictorial representation of a system or a model. So these are widely used in control system, signal processing and electrical engineering, and the main purpose of this block diagram representation is to find out what are all the components needed to implement a system, either in hardware or in software, or how much of memory we need to implement such a system, right? So it's very important in the case of systems. So this is the definition of the block diagram. A block diagram is a graphical representation of a system showing the functional relationship between the components. Okay. The next is the basic elements of a block diagram. So these are all the basic elements which is there in the block diagram representation. The first one, the differentiator, you can see here, this is the symbol of the differentiator. A d by dt we can write in a box. You can put a d by dt, or in the S domain, in the S domain we can represent it as a box with the S. So x of s is the input, and in the output you will get s into x of s. In the time domain, x of t will be the input, and the output you will be getting d by dt of x of t. Okay, the differentiator, or we can say it as a delay element. The another one is the integrator with zero initial conditions, right? So x of t integrator represented with a block with the integral symbol. So the input is x of t and the output is integral x of t into dt, and here the S domain representation, x of s is the input. So alternately, integrator we can represent it as 1 by s in the S domain, right? Or the output will be x of s divided by s. And another element is the constant multiplier. Here the input is x of t. So this a represents the constant which is to be multiplied with this x of t. That is why it is called as constant multiplier, right? So here in the S domain it can be represented as x of s, the input, and a constant multiplier a, the output is a into x of s. Similarly, you are having another one element, that is a signal adder. Here x1 of t and x2 signal, 2 or more signals can be added in an adder, or this is called a summing element. So x1 of t, the output will be x1 of t plus x2 of t, or in the S domain we can represent it as x1 of s plus x2 of s. So in the in general, so already we have discussed about this differential equation representation of a continuous time system. So this is general representation of a continuous time system in the differential equation, right? So a naught into d power n divided by dt power n. So an nth order differential equation. So this represents a continuous time system. But in the case of discrete system, you must remind that we will be using difference equation. So here it is differential equation. So it is an nth order differential equation. So actually these differential equations are a set of equations that represents or that characterize the complete system, right? So this can be, so in the S domain also, so if you take the previous differential equation, if you convert it into S domain, you will get the transfer function model of the system, or h of s equal to y of s by x of s. So that equation can be represented as in this way, or this is the as a function of, a rational function of s, we can represent this equation as y of s by x of s in this form, right? Because we can represent, or we can model represent a system in block diagram both in time domain as well as in S domains. So here for each set of that differential equation, so we can construct a block diagram, so that consists of all the basics elements. So we have I have already told earlier. So such a block diagrams are we can call these block diagram as a realization of the system, or structures, right? Structure realization. And we can rearrange the set of differential equations to reduce the computational complexity, or and memory requirements, because here in block diagram representation we have different types of structures. So we can have different types of structures: the direct form 1 structure, direct form 2 structure, cascade structures, and parallel structures. So many other structures are also there, but here we are going to discuss about only direct form 1 structure and direct form 2 structure, what is universal levels, right? So this different types of structures, so it is your duty to analyze the advantages of all these different types of structures. So each one is having its own advantage, right? And what are all the disadvantages of these different types of structure realization? So here in the direct form 1, so let us see this direct form 1 structure. Here you are having the S domain representation of that differential equation we have already seen, right? So in the previous slide we have seen that S domain representation. So here we can write this S domain representation as y of s equal to minus a1 y of s by s minus a2 y of s by s square, etc. up to an. Similarly here you are having the input in the S domain, so b0 into x of s plus b1 into x of s by s up to bn into x of s by s power n, and this can be represented as a block diagram like this, right? So here you see x of s is the input. You see this input side representation b0 into x of s. So x of s is multiplied with the b0, right? It is added in this adder. The next term is b1 x of s divided by s. So you need an integrator. It is represented as 1 by s. So x of s is given to an integrator. The output is x of s by s, and it is multiplied with the constant multiplier b1. So once again it is added here. Understood? So these two outputs are added at this point. Similarly, all the x of s terms are here you have added, and this output is added with this y of s terms, right? So here you are having the y of s term. So minus a1, first term is minus a1 into y of s by s. So here you see this is my y of s. So you are getting this y of s through an integrator 1 by s, and you are multiplying it with the minus a1. Understood? So once again it is added here. So similarly all other terms are also added here, and the final output you are getting this final output as y of s. So this is the direct form 1 structure. So this integrator, actually this integrator represents the memory element. You see the number of memory elements, number of multipliers and number of adders used here in this structure, direct form 1 structure. The next one is the direct form 2 structure. So in the direct form 2 structure, here we can rearrange that terms in y of s by x of s, that is h of s, into two parts, right? And for each section, so similar to a cascade realization of two sections, we can subdivide that y of s by x of s into two sections, and for each individual sections we are making this block diagram. Understood? So we will discuss this with an example here. You just remember the difference between these two structures. The first one, the direct form 1 structure, here you see all these delay elements are at the beginning, right? And these delay elements at both sides of this direct form 1 are combined, right? So combined together in the direct forms 2 structures. You see here these delay elements come in the middle of this structure. So these two delay elements are combined to get a combined structure, and these multipliers are in the both sides, right? So this is the direct form 2 structure. So here you can we can see an example. So the question is, you need to draw the direct form 1 and direct form 2 structures of the system, right? You can see this if you take this Laplace transform and if you rearrange this equation, you will get y of s equal to like this, right? So so here you see the direct form 1 structure as we discussed in the previous slide. So x of s, right? So through an integrator, x of s term, you see here in this is the x of s terms, right? The input terms x of s, then 0.5 into x of s by s. X of s is given to an integrator, so you are getting the output as x of s by s 0.5 and an adder, right? Similarly, the y of s terms, here it is connected. The outputs are connected with the multiplied with the multiplier, and then it is added here in the summer or adder. Okay, so we are getting the y of s. Similarly, you can directly convert this equation, this direct form 1 into direct form 2 structure by combining these the integrators together and redraw this circuit. You will get a direct form 2 block diagram like this, right? Or we can subdivide this y of s in x of s into two portions, w of s by x of s into y of s by w of s, right? So here in these two subsections, so this w of s represents the output in the first subsections, right? In the first subsections, the w of s represents the output and x of s is the input, right? So in the second subsection, the y of s is the output, that is the final output, and w of s represents the output from the previous section, right? So this is the w of s is the output of the first section, and then this output is given as input to the second section, right? Or we can say here it is the x of s, it represents actually the poles of the system, right? So first you are making this poles into block diagram, and next this y of s, the numerator of this represents the zeros of the transfer function. So you are making that zeros into a block diagram. I think you got some idea about it. So you need to analyze these things at your home, and please do discuss about all these things in the classroom tomorrow. Thank you.